Recording in progress.
Hello, everyone. Thank you for joining in. Welcome to the Industry Talk 2. So we had earlier organized Talk 1. I'll be sharing the links of the web page where you will find the information about our industry talks. Even this session is being recorded and the recordings will be available later on. Before I get started with the talk details as well as the overview of NS3, just a bit of logistics. I kindly request all the participants to keep your microphone muted so that we can have an uninterrupted session from our speaker, Jing Zhu. If you have any questions, please use the Q&A or the chat, and I'll be helping Jing Zhu in managing the questions. At the end of the sessions, we will take all the questions one by one and try to see that we can answer. Please keep the questions specific to this particular talk and something that is related to this talk so that we can make the best use of the time of the speaker who is available with us. Moving forward, let's talk a bit about NS3. So for those who are new, it's an open source packet level network simulator which is oriented towards network education and research. And basically, we also have the ability to run real code, and also NS3 can interact with the test beds. We have been participating in Google Summer of Code from quite some time. We also have active projects this year in 2025 on Google Summer of Code. I'll share the links where you can find this year's projects as well as the projects from the past years. We also have something called NS3 Summer of Code. For some students who are not able to make it to Google Summer of Code, we try to provide them an opportunity to work with us if the project is interesting and the mentor is available via NS3 Summer of Code. This tool is currently being used across various industries, and the motivation why we are organizing these kind of industry talks is to primarily understand what are the use cases of NS3 in industry, how is NS3 being used in industry, why do industry people feel the need for NS3, and is there anything that they would want us to add to NS3 which is more relevant to the industry so that we can maximize its usage across industries and also train these students in their universities before they get on to a job so that they are skilled with these kind of tools, and also, of course, to enable interaction among diverse set of users which belong to academia, which belong to industry, and so on and so forth. Moving forward, these are some of our important links. The main website, the wiki. We also have an app store. So we have plenty of apps on the app store that are not a part of the NS3 mainline, but they are still pretty actively used. So please try to go across App Store and see if you find an app that is of your interest. We have a lot of our active developers and maintainers who are online on Zulip, so you can catch them and talk to them. We have a developers list, so users list. If you have a user specific queries, you can put it in the user list. If you're coming up with a new module you want to propose or you're developing it, please put it on the developers list and seek feedback from the community. We also have active GSOC and NS3 Summer of Code projects. This year, we do not have any NS3 Summer of Code project. We have GSOC projects. The link is common for them. And we also have the international conference on NS3, which was earlier known as the workshop on NS3. Now we have renamed it. We have the call for papers open for lightning talks. The call for the main program is over. The paper reviews are done, and the accepted papers are already listed on the website, but we still have lightning talks open. So if you are interested in proposing a lightning talk, please go ahead and propose your talk for the presentation. And we also encourage remote presentation in case you are not able to travel to Japan. This year, the international conference on NS3 is being hosted at Japan, and the dates are 19 to 21. So please feel free to submit your lightning talks. The more information is available on this website. Let's move on to the speaker. We are very glad to have Jing Zhu with us, basically. He is a founder of the Network Simulation Solutions, and this is a brief profile. So he received his BS and MS degrees from Jing Zhu University, China, and PhD from University of Washington at Seattle. He has more than 2 decades of experience in system design and performance optimization for heterogeneous multi-access and radio networks, which includes 4G and 5G cellular networks, high-density wireless LANs, satellite communication, and mobile ad hoc networks as well. He was formerly a principal engineer at Intel, where he led the research in next generation multi-access networking and also developed open source platforms for network AI simulation as a service. He has also contributed to many standard development organizations like IEEE, 3GPP, ETSI, and Internet Engineering Task Force, particularly helping to drive the convergence of these different wireless technologies. And most recently, he has founded Network Simulation Solutions, which is a startup focused on advancing open source network simulations through the network simulation as a service model. We are very excited to have you, Jing, and looking forward to your talk. I'll stop sharing the screen. You can start sharing, and I'll confirm whether we all can see that. You are on mute in case. Yeah.
Thanks. Thank you, Mohit. Yeah, let me share my screen. Yeah. Let me know if you can see the screen.
I can see it, and it's maximized as well.
Okay, perfect. Great. Yeah. Good morning, everyone. Good afternoon, good evening, depending on where you are. So today is my great honor to be here and talk about our most recent work, Web-NS3, a cloud-based network simulation as a service platform. This is also the first product of our company, the startup that I funded last summer, basically. And together with me today is also Professor Sumi Roy. He's our chief scientist, and he also was my PhD advisor while I was doing a PhD in University of Washington. So it's a great pleasure to present this work together with my previous professor advisor. And also this work, I got a lot of good feedback from Professor Ye Li from China, and also my team member Menlei Zhang. Okay, so in today's talk, actually, I will divide this into two parts. The first part, I will talk about this platform, the motivation, the design, and the key features, and we'll go through the key steps of the typical network simulation workflow. And then in the second part, I will mostly showing several demos, live demos, to highlight the key features and the functions of this new platform. So yeah, feel free to, if you have any question, feedback, yeah, we would like to hear that at the end of the talk. So first, I'd like to give a few words about this company. So Network Simulation Solutions, I found this company last summer after I left Intel. Actually, Intel is my first and last company that I work for. After I graduated from University of Washington, I was mostly doing wireless standard research at Intel. And throughout the years, we have been using network simulation tools like NS3. Actually, when I was doing PhD, I was using NS2 right at that time, 20 years ago. So we know that NS3 or network simulation tool is absolutely critical for wireless research and development, especially even for the industry, right? And academia as well for learning and teaching. So when I found this company, my vision really is about to bring down this barrier for more people to benefit from these great tools for their everyday research and I would say work, right? And they can use NS3 as easy as possible to do all kinds of jobs, right? For simulation, for performance evaluation, for developing new protocols, for teaching queuing theory and all different aspects of networking and wireless systems. So we found this company, and then basically over a year, we developed this new platform called Web-NS3. So today I'm going to talk more about this the tool that we developed together with the team. So I think when we start developing this tool, the main thing we have been thinking about is that as mentioned, that basically network simulation is very important and a critical tools for next generation wireless technology development. However, the simulation tool has always been a bottleneck for innovation because we know that when we design something, we have to somehow validate it. And because wireless network is getting more and more complex, it's just involved too many layers, of protocol implementation, it's almost impossible to develop or write your own simulator from scratch, right? So that's why we rely heavily on existing simulation tools like NS3. As a matter of fact, that we know there's no very scalable commercial network simulation software. I used to work with OpenNet when I joined Intel, but then later we find out this kind of proprietary tools has many limitations. It does not iterate as fast as open source software. It does not leverage the I would say the community efforts to work together to improve the simulation tools. So eventually we decided to transition from the commercial tool like OpenNet 2 and 3. So basically most of my years at Intel we are using N3 as a main tool for all the wireless performance evaluation and standard development. But however, we know that N3 or open source tool has also its own limitations, right? One of the key challenges is the usability. Because it's open source, it doesn't have an entity or a company behind this tool to help support maintenance, support the question and answer. It mostly rely on the email group, right? Google email group to provide the answers. So sometimes it cannot be quick enough for people to find the answers. And also, once you have these questions, it's hard to basically get those problems resolved as quickly as possible. And the other problem with this current simulation workflow is that you heavily rely on standalone installation, right? So you have to have an environment at your own desktop or laptop, and many times you have to install a virtual machine to host a Linux operation system, and it just does not scale with the compute resource that may need to run those simulations, and you cannot leverage a cluster of compute resources to speed up your simulations. So that's another, I would say, a limitation of open source simulation tool like N3. So with all this, we see an opportunity to really modernize the N3 with cloud and also the recent AI ML that's becoming obviously everywhere for all different aspects of the industry. So we try to build this new platform called Web-NS3 to combine it with a cloud-based scalability and intuitive web interface and enable AI ML in the loop simulations. And because we are a startup and I'm a true believer of open source software, so we try to leverage the existing open source simulator as much as possible, mainly the N3 simulator and the Network Jing framework that I developed when I was in Intel is also open source project to enable AI in the loop simulation capabilities. So now let's talk a little bit about the key features that the Web-NS3 offered. So it's basically a cloud-based simulation platform, right? The simulation engine is hosted on the cloud, and then it provides this web-based interface. And you also have this AI/ML workflow to enable you to run algorithm agent together with a simulator as the environment to generate data. So some of the key features are listed here. The first one, obviously, because it's hosted on the cloud, so we do not require any installation. And because it's a web interface, it's not the typical Linux command line interface, and you can easily configure, modify, edit everything on the website browser. And also we provide all the examples that's supported by the N3 source tree. And you can easily select any example to start with and then build your own simulation scenarios. Because the simulation are hosted on in the cloud, we are able to leverage the cloud scalability and basically bring more machines as needed to support multiple simulations in parallel. And you can also visualize the data easily on website. We provide multiple ways to visualize data, and I will introduce these methods later in this talk, and particularly in the demo session. And we also integrate the Jupyter Lab, a very powerful data processing tool that allow you to write your own data processing script with Python if you want advanced kind of visualization capability, analyzing the statistics generated by the simulator. You don't need to install any of the Python library on your local machine. You can run everything together directly on a browser. And more, he also mentioned the NS3 App Store. Here, we actually make it much more easily used for users. Instead of just have you to download, install individual NS3 special builds, we already install all of them or most of popular ones in the cloud. So you can select them before you start your simulation as basically you select a baseline NS3 build. And this can be a default build or any of the existing build on the App Store. And here, if you have anything that is not listed here, or if you would like to use some of the other NS3 builds, feel free to email us. We can include them in our library. So now let's talk about the basic workflow for Web-NS3 simulation as a service. It's involved mostly 7 steps, right? You start with, as I mentioned, select a list from a list of NS3 builds, right? You can choose any, like for example, we know there is a 5G NS3 module, right? It's not part of the main NS3 software stack, but here we provide a list of the popular ones, and we keep monitor the community efforts, and we will include new ones as then appear in the community. And then once you select them, you can now see all the example that's already building in this NS3, right? So from all these examples, you can start build your own simulation scenario. You can also write your own script directly for advanced user. If you know how to write the script from scratch, you can also do that and upload the file directly over this web interface, right? After that, we have a window that you can then start editing your script and provide all the runtime arguments. And we also support 2-dimension parameter sweep, so you can actually run batch simulations and then sweep the key parameters that you're interested. And we also allow you to upload any additional supporting files. For example, you can provide trace or data files as an input, and also additional library files when you compile, right? So that's kind of the other things that you can provide through this web interface. And once everything is completed, then you can simply just run the simulation and then monitor the simulation progress. We actually have an interface to allow you to see all the output, terminal output of the simulation. So for all the error messages, all the print out the messages you can see from this terminal output, right? And then you will see the simulation is completed, and that way you get all the trace file or data file, and then you can create online these 2D graphs if the file are formatted as CSV or TSV, like Excel like a file. We also support the default GNU plot format, right? If you use that library in S3, you can also see the graph directly on the website. And last, if you want to do additional processing, you can actually download all the files and then use Jupyter Lab, which are part of this web service. We are integrate this library, and you can run that with your locally downloaded file. Okay, so that's kind of the 7 steps. And then next, we will introduce each of these steps with a little more details. So do we allow question, or we want to hold question at the end of the talk?
Anything is fine, Jing. If you would like to take any questions, we can do that.
Yeah, let's do that. Let's to see if people have any questions before I move on to more detail.
Sure. So I would request the participants to please put the question in the chat, or maybe raise hand and then unmute. I can also see some participants are, using the annotator. So if you may please avoid using it because it's going around the PPT. So it's kind of a bit distracting. So if you can avoid that. And yeah, we are open to questions before we get into demo. I think after this thing, we have demo, right?
After this, I will talk about the details of each step, and then we have demos. Yeah.
Okay, perfect. So, okay, I don't see any hand going up. Maybe I'll keep an eye on chat box and I'll let you know if there is something. Okay, we have one question.
Okay.
You can see the question is, what is the state of the project at the moment? Is the web service accessible at the
Oh,
moment?
yes. So right now we are doing alpha testing. So we have our initial service available on this website, right? n3.netsolutions.com. All you need to do, go to this website, register with your email address. You will get a temporary password, then you have the access to the service. Okay, thanks for the question, though.
Yeah.
Okay, let's continue. So basically, so at the very beginning, once you access the website, you get your login information. So this is the first step is to okay. So the first step is there you can see the website, right? The layout at the very top. There's a few tabs, and you start with the catalog, which you can select, as I mentioned, one of the listed or supported N3 build in our cloud environment, and we have include the most recent 3.45 versions, and then the previous version 3.44. We have also built with the Network Simulator, the latest version with that build. And then you can see other popular N3 App Store kind of software stack. And we definitely welcome if you have any suggestion to add any additional, if you know some of the other N3 builds that are popular, just let us know. And when the other feature at the bottom of this in this catalog is the customized repository. This is only available for pro user. So actually, I forgot to mention the service currently offered as a two service tier. There's a free tier, right? You don't have to pay anything. You can get access to the environment and run simulation. There's also a pro tier. So it's currently priced as a $9.99 a month. With the pro tier, one of the key features that allow you to do is to create your own N3 build. And there are two ways to do a customized repository. One is to copy any of the existing builds from the environment in the cloud, or you can actually clone from the Git repository anywhere on the internet, right? So if you say, for example, if you want to run any old version of N3, you can actually go just directly clone that version from the Git repository. And if there any N3 repository we are not included here that you would like to try, you can also do that, right? So after this, you will actually create. I'm seeing here at the last of this list is your customized, and you can also select that one as your N3 build baseline to build your simulation scenarios. Okay. And then there is obviously the links, right, associated with each of the N3 build. You can find more details about this the software, the N3 version we include in the list. So second step, after you pick one of the N3 repository, you go back to the Start tab, and then here you have two way of build your first script. The first option is just to upload your own script. The second one is to choose from any of the existing example that's actually part of the N3 build, and then start from that, right? So this way you just need to make some modification instead of writing everything from yourself. And once you click that, you will see there's a pop-up window allow you to name your simulation. So the way that we do this is that for each of the scenario, you can only have a unique name. So you need to have different. If you cannot choose multiple simulation with the same name. So name is basically identify the simulation instance that you create. Then after that, once you upload these or create a new simulation script, you will go directly to this editing window, and then you can go back to this use dashboard to see all the simulation you created. but for the most recent, you just created one, and then you can make the changes in this editing window. And if you have a small screen like smartphone, you can actually use a full screen to see the file with a larger make it larger to easier to look on the small screen. And you can also just create a new simulation. As I mentioned, each name represent a specific simulation instance, and you can create multiple ones with the same script, and then just basically create a new simulation with a different name. And on the right-hand side, you can configure the simulations. There are a few configuration options. The first one is you can actually configure how many times you want to run the simulations. So in the back end, what we do is for each run, we will assign a random seed. So you can run 10 different 10 simulation with the same configuration, but then a different random seed. And then we also allow you to put in any runtime parameters for static for the fixed values, right? If you have a fixed value, you put in this runtime arguments. If it's a parameter sweep, we have another configuration that you can choose what parameter you want to sweep and what are the values and what are the steps. And then also we allow you to provide additional trace files. Later, I will show a quick demo to show how you do this with a file configuration. Okay, so after that, you have mostly configured all the simulations. You just click the run simulation to kick off it. And then you can start go into the dashboard and then see all the progress of your simulation, right? And here, these 3 dots, actually, when you click it, you will see different options. You can actually see the output when you run simulation. If simulation completed, the progress bar will show as 100%. And you can go back, edit the script. You can also delete the simulation. For the free tier, we have a limited storage. So when you run out of the storage, you will not be able to start any new simulation. So you will have to delete your old ones and then start or create new ones. You can download all your results and scripts, everything for this particular simulation scenario. You can also do that, download everything in your cloud environment, which basically include all the simulation you have created, all the results have generated in the past. All right. And then after that, you can go either download the file for offline data processing or to just see the results online and then create graphs using our online tools. So this is one of the example of how you will see or create your own online graphs. After your result simulation is done, you click the results, you will see all the traces files generated under this window. And if the file is formatted as a CSV or TSV, you can actually see the right-hand side where the file will be shown up as like the Excel sheet, a table. You can also have the option to switch between a text version of the file or a table version of the file. And then you can configure the x-axis and y-axis for drawing the graph. And we also allow you to draw multiple lines based on your trace file. And so you can group the data based on a third parameters. And then you will just be able to click the show graph. It will be, you can see the real time the data of this trace file, right? And we support 2 types of the graph, line graph and the bar graph. And also on the Y scale, you can do a linear or logarithmic Y axis. You can switch in between. All right. The last step is the post-processing. So here you basically download all the files, and there's the Jupyter Lab tab. You can click that, and then there's a local file access features. Jupyter Lab, I mean, there's details you can learn how to use Jupyter Lab. Jupyter Lab support mostly 2 modes. One is you can upload the data file and your script to the Jupyter Lab OS environment. This is a web OS, and then you process in the web environment. or you can put everything locally and then basically process your file in a local folder. This is a way that I would recommend you to do because that way you can keep all the file in your local folder. You just need to download the trace file and then do the processing. Okay, I think that's the last step. Oh, this one, yeah. So the other one I mentioned that for the pro user, you can actually build your own customized N3 version, right? Once you create the clone or copy any of the existing N3 source tree, you can go to customization tab and then see all the files, right? That you cloned or copied. And we allow you to modify the source or contribute these two folders, right? The other folders you can see, but you cannot modify. And for these two folders, you can easily make edits, like create new folders, create new files, upload new files. And if the custom view is cloned from Git, you can always choose fetch. You can also fetch the latest from the Git. So this will allow you to keep update to the latest version on the remote Git. And this also allow you to do a kind of a Git in the loop editing, right? So basically you can create your local Git, I would say version like Visual Code, and then you can edit the entire source tree in the Visual Code, and then you commit changes to the Git, and then you can fetch the Git from the using this method, right? The benefit here is that we don't provide a IDE for code development, right? If you really want to make large changes to different code or files, it's better to use existing tool like Visual Code, and then you commit changes to the Git, and then you can fetch changes from the Git using these features, right? So that's for the main for large code changes. For the small changes, then you can just go directly to the file and then make changes to the file. After that, you can choose one of the three options to build the N3, the optimized build or debug build. This is a two build version that N3 supports. And then the fast build is just whatever the last build that you choose or more the last one that you build. The fast one is just build the change, right? For the debug and optimize, it will do a clean build. It will basically build everything from scratch. Okay, so that's kind of the main part of the talk. Let's see if there's any questions I can answer at this point.
Yeah, there are two questions, Jing. I'll read it out for you. The first question is, any plans to build Docker version of this?
Sorry, what's the question? I didn't get that.
Any plans? Do you have any plans to build a Docker version of this?
Oh, Docker. Not. I mean, this is really our kind of a backend, right?
Right.
So we are not releasing any of this as an open source. So you can see the N3 part is complete open source, right?
Yep.
But the simulation as a service is a service, a commercial service we are offering. So we all that part will be a proprietary. Yeah, we are not offering Docker. Yeah, no.
Sure. Okay. We have another question. Will each run have a different random number generator seed? Will the random number generator seed change in a deterministic way for every run that we do?
Yes. I mean, basically, we choose a random number for, let's say, if you run 10 times, right? So we will choose a specific random number for different numbers for its deterministic number, random number. We see random seeds configuration, right?
Right.
For that run, yeah.
Okay, so basically, when a user would run the same simulation again and again, will the seed value change or will the seed value remain the same?
Will change, yeah. That's the key point of random seed configuration. Yeah, for example, we can set the random seed from 1 to 10 if you have 10 runs, right? Yeah.
Yep. Okay, perfect. Okay. We have two more questions. We can take those and then move. Any other questions we'll take later. Is there any way to visualize the network scenario using visualizers such as PyViz or NetNM or NetSimulator or any other method through your cloud service?
Okay, very good point. So we support Net Visualizer, right? The latest version S3 support Net Visualizer is a 4.4 or 44, I believe. So the idea is that they generate a file, right? A JSON file. So we don't have web version of seeing that file. So you have to download that file and then do that locally on your own machine. So I guess the answer is yes or no. We do generate the topology of file, but we are not integrating the Net Simulator into our web interface. Yeah.
Okay, makes sense. Yeah. We'll take one more question, then we'll proceed with the demo. When saying making network simulation more accessible, the person who has written in the chat says that the first thing that came to their mind was a user interface that allows to lay nodes and draw network visually. Will a user interface be a plan for the company?
Yeah, that's definitely a future plan. Yes. So we do want to avoid writing any code, right? So so you use web as an interface to put just drag and drop, deploy, right? And then you can run simulation. Yes. So that is part of the plan. Yeah. As a matter of fact, we actually try to pursue some additional NSF funding to support that efforts. Yeah.
Okay, perfect. Sounds great. I think we can proceed with the demo, Jing.
Okay, great. Let me go to this. So yeah, so first demo, I will just to show you how you can build your first example, build your script with your example, and then upload any input file, right, to run simulation with additional trace file provided from your own machine. So in here, I'm going to use this very old one. It's just a mobility test example, right? Full motion S32 examples. Once you create this new script, and you can see this is the code, the file. And as here, you can see there's a trace file that's used by this script. And here is where you need to provide the inputs. And we'll simply upload a file. So this file is part of the S3 build. When you run the example as part of S3, this is already exists in the source tree. But because now we create as an example, you cannot access the source this way directly. So you have to create, upload this file as additional input file. Once you provide this file, you have to change the location of this file, use relative path. Okay. So that's all you need to do, and add this as your path where the file will be stored in the cloud. And you can click save, and we also enable auto save periodically, maybe every 10 or 20 seconds, it will save automatically. But you just want to make sure that you can always click save. And now you can just run simulations. And here you can go back to the dashboard and open the output and see the results, right? So you can see that this is what you will see if you run this locally on your command line interface. And this is actually the trace file of that input. Okay, so that's the first demo. You have basically see that now this new scenario is created, the status is complete, and the progress 100%. From here, you can click result, but this one doesn't have any CSV formatted file, so you cannot draw a graph, but you can see the terminal output files. Let's go to the next demo. So in next demo, I'm going to use LT handover as example. We'll create a scenario with existing example, and then we will make some changes to the code and run the simulation. Here, I want to show how we visualize the data if the file is formatted as a CSV data. So again, you can search handover, go to here, you can create this test. All right, so here we're gonna make changes to from 500. So in this demo, it's a very simple 2 base station, 1 UE, right? It moved from one base station to another base station. As you can see here, the distance configuration is controlling the cell size. and how far the UE will travel. So we make it smaller so the simulation can run quicker. And we save it. Now we just run simulation. All right, you can see that the simulation is completed, and there's some printout a message, basically the traces of when the handover started, when it's completed, right? And we go to measures. This time we will see the trace file. As you can see, this is all the file generated by this simulation. Here we want to, let's see the signal strength. And because this one is formatted as a tab separated format, and you can visualize the file in a table format. And here, if you have too many columns, you can actually manage to just show the one that interested to you. Okay, so let's just to see. Okay, so you can see now at the time, and then which cell the UE is associated with, and then the signal strength. And now we can draw a graph of signal strength when the user moving around by cell ID. All right. So here you can see two colors, right? Basically, these are two curves. Each curve represents one base station, and then the handover happened around this time. And because now we are showing in a linear format, so it's not very easy to see. We can switch it to yeah. So now the log format, you can see the signal strength changes more clearly, right? The handover happens around this 4.3 time. All right. So that's the second demo. So in the third demo, I will show how you can upload your own script and then do a parameter sweep, generate multiple runs, simulations, and then do offline data analysis with Jupyter Lab. This way, you can draw a more advanced kind of graph, like cumulative density functions or probability density functions, right? So those things that using Python statistic tool. Again, we go back to start. We upload file. So here we have a queue system test. Okay, this is the file. And this example is provided by Professor Ye Li from China. And this is basically run a MM1 queue. And then you analyze the queuing statistics. And you can configure the queue size, the lambda, the arriving rate, the serving rate, right? So here, let's run this with a parameter sweep. I will sweep the lambda from 1 to 1.6, and then with a step of 0.2. Okay, that's it. So in this kind, you can see it's actually run multiples with different parameters, right? So let's go to the dashboard, and then we will wait till this finished. You can always check the output. Yeah, so now you can see it's already 1.6. Yeah, so it's finished. And then here you will have multiple runs. So for each run, we will have this folder named with the run index and then the parameter that you have configured. And here you can see each of the results for each of the run. And this trace, we can first see the trace just quickly. So it has two states. One is arriving, the other one is departure. And then the plus means arriving, minus means departure. And then you can see the queue size when a packet arrive and depart, right? And if you want, but however, we don't draw CDF, PDF, right? Let's say if you want to draw a PDF, CDF, then you have to first download the files. Go back to the queue system, make a download. Okay, so you can see all the trace in this folder, right? So when you download, actually download entire folder in the simulation. It also include the terminal output and your own scripts. So this can be a way that if you want to keep a copy, store everything locally, that's also a way to do it. So let's copy this trace file. This is my local folder, right? Oh, yeah, I have to let me extract first. Okay. Now you can just copy this file into the demo 3. So I already made a copy, so let's just not do that. Now let's go back to this web interface. You can click the Jupyter Lab, right? This will be the interface that you do with, use Jupyter Lab to do the post-processing. And then you open your local folder. You will see this is your local folder, right? And you download all your trace file in this folder in the trace. And then the scripts, the Python scripts for, you already have your local Python scripts for analyzing the data. And here you can see we can draw basically any graph, right, with Python tools and CDF, PDF, and any statistics. So that gives you more flexibility to do post-data processing. Okay, so the fourth demo we will show is to use glue plot, right? So the glue plot is the old way in S3 to show graph that's kind of generating a GNU plot data format file, and we also support that. In this case, we're not run simulation from beginning just to save time. We just have already run the simulation, so we can just see the result directly. Yeah, so this one we already completed demo 4, and you can go to the results. And this file is generated by S3 using glueplot library, and this is the file content, right, in the text format. And in here, you don't need to configure anything because it's already configured in the file. So once you do a plot, you can, you can directly see the graph here. Okay. So this is a different, I would say, another way of doing data visualization if you like to use plot. Currently, we only support a simple 2D graph. There are other plot formats, GNU plot formats. We don't support at this moment. Maybe in the future. Okay, so the fifth demo we'll show quickly here is again a parameter sweep. But this time, what we like to do is to generate a data point for each run, and then combine all the data into one graph, right? So that's actually a more advanced use of a batch run. Let's see. Yeah, so this distance one, edit. So here, what we do is we basically try to draw a PER curve versus distance in a Wi-Fi network, and then for different MCS level, right? So, no, sorry, not this one. Actually, Wi-Fi link performance. Yeah, this one. Yeah, so it's a simple like 2 nodes, right? You can see here. We just change distance. We try to find the packet error rate for each distance with different MCS. And here are the configuration. This 2 parameter sweep. One is the distance used from 30 to 40, and then MCS level. This is MCS index, right? We have 3 different MCS index. We have already run the simulation, so we can directly go to the results, right? Performance. Okay, so here, similar to what we saw before, each of run, the run index, then the distance, and then MCS level, right? And it will generate a terminal output, and then it has only 1 data point, right? Here you don't show the trace. You want to actually combine all this file together. Again, the system will combine all the results automatically. So now all the traces actually in this combined file. Now you can draw the data in different way, not in a trace format, but in a more kind of statistic way. Now let's use distance as not time. This is time. We use distance as the x-axis, and then packet error rate, and then MCS, right? So now you can see that the 3 curves generated. Each curve represents a MCS level, and then the x-axis is the distance, and then y-axis is a packet error rate. You can use bar curve. You can use line curve. Okay. So again, we try to make this as easy as possible, right? So this will be generated automatically, combine all the results. And since this is alpha release, so if you have any feedback, how you like to see the data and visualize, we definitely welcome your feedback. And the last one, but not the least, we just quickly show how you create your own customized build, right? So as I mentioned, there's two ways to do this, right? You can always pick any of this. Say I pick 5G NR as my starting point. You can just choose one of these options. You can create custom repo. You will in the backend, we will actually copy this build into your own folder, and then you will be able to see. After you copy this, make sure you go to customization and click one of this. Since this is the first time, you can choose either debug or optimize mode. Debug mode allow you to print out the debug message. Optimize mode is quicker, right? So let's say we just build this optimized mode. You can see the code here, right? Source, and you can upload download file or the folder. You can actually download the entire folder of this build just for your own kind of editing purpose. And then you can see the file under the source or contribute folder and make changes, right? Let's go back to the dashboard. Yeah, here same thing. Once you create this build, wait it to complete before you build another one, right? And then you can always see the terminal output and the progress, and all the error message will be here as well. All right, so that kind of concludes our demo session. So we have probably 5 minutes left. Let's give this to the question. Yeah, if you have any questions, we can do that.
Yeah, we have a couple of questions, Jing, but thank you for the demo. The first question that we have is, does it have library to support security issues in 5G network? And will it support 6G parameters in simulation?
Okay, so again, I want to make a very clarification is that my company currently we do not do NS3 simulator development, right? So we don't develop new features of NS3. Rather, we use whatever is out there in the community. What we provide is really a service to allow you to use any of those existing NS3 versions and make it more easy and integrate integrate with visualization, all that, right? So yeah, the short answer for that is no, we don't have that plan at this moment.
Okay.
But
Next,
if you know any of existing S3 out there that support this kind of new capabilities, let us know, and we can make available. And since we support Git cloning, you can also clone directly from that repository, just to make sure that the report can include the entire S3 tree. Because we know that many of the repo they only include the module, the contribute or source kind of folder, not the entire S3 source tree. So for the cloning to work, you have to have the entire S3 folder, yeah, to be able to make your customized version, yeah.
okay. The next question we have is, what features would you like to see implemented in NS3 that could benefit Web-NS3?
Yeah, that's actually a very good question. So I think that's actually the relate back to the question related to the deployment, right? So what I really like to see is that right now the N3 is using C script, C++ as a starting point when you write scripts or run simulations. What would be good is if people can start develop examples with a configuration, like JSON configuration as inputs, right? So share the same scripts. So I really like the N3 community to start build examples around that. Like for example, if we go back to this one. So right now I have all these examples. All these examples are actually C++ examples, right? Scripts. It will be really good if we can start developing what I call JSON configuration based examples, which means that if I pick any of this, say, Wi-Fi network, right? I start here. I don't want to edit these C scripts. Rather, it will be a backend. You will never change the C scripts. The file will be running in the background. It will take an input file, say JSON configuration file, which will configure topology, configure the data source, traffic model, channel model, all this, and measurements, right? So that way, all this will be just a JSON configuration. People can edit that JSON configuration file, and then the C+ file will read that configuration file. This way, you can actually configure different. I mean, right now you are just doing this through a parameter, right? You have lots of parameters, but that's not very straightforward. It's easy to read. It's difficult to modify or read. So if we make a JSON file, and later if we have that example, what I can do here is bring that online, right? And now if you have a JSON file, it's very easy to convert it in a graphics environment where you can actually read or create a graph or create a drag and drop capabilities, and then generate that JSON file, then kick off the simulation. So I think that's another, I think that will be my immediate wish list is one of my wish list is to actually have that JSON configuration capability and then drive the simulation. And that will be, I can start building this topology configuration through a GUI interface, not these text files. Yeah.
Right. All right. So we'll have last three questions. I'll close the queue after this. So there's a question that will the configuration of the machine on which these simulations are being run at your side, will they be made available to understand what is the configuration of the machine? And there's a related question for you.
Okay, so remember, we are not doing this configure. If you are interested to know any of the configurations, most of these are actually available from, I mean, I actually, this is not the N3 build I develop or my team develop, right? We actually we follow the instructions from the owner of this repo, right? Or whoever the repo we use, whichever repo we use. So there's a two way to do this. One is you can contact the owner of the repo. We provide the link directly. You can also contact us if you run into any configuration problem. We will try our best to address that. But there's nothing really we can share. It's owned by the the user, the owner of the repo. That's the best person who can answer your question, I guess, for any configurations. Yeah.
Basically, I think this configuration was a computer configuration, not the simulation configuration. So it's basically the user, the participant is asking the question as to what kind of CPU architecture or what kind of resources you are using in the cloud to run these experiments. The same participant has asked the related question that is this Web-NS3 oriented for beginner or mainly for people, those who have limited computing power?
Oh, okay. So, yeah, I mean, we don't disclose the our backend capability. Obviously, we try to bring the fastest or best with our budget limits, right? To make sure it can run as fast as possible. Yeah, so that's our goal. I mean, it's not just for you to run a small simulation. We want this to be able to handle a large simulations, right? We all know N3 is a single thread. So therefore, it requires very high CPU power. So we try to have that capabilities. Yeah, but we do not disclose that part. Okay. So you can actually measure it because one thing I forgot to mention is that we actually have if you download the data, it actually have a data showing the simulation time. So you will be able to know how much time that your simulation, you can actually compare against your own local simulation, right? So although we don't disclose, but you can have idea of whether it's faster to run this on your local versus cloud. Yeah.
Okay. The question next one is it possible to run a modest data center scale simulation that evaluates different network and routing configurations, impact AI/ML training and in inference performance?
Yeah, so there's two parts, I think, this question. First one is data center capability, right?
Yep.
So I believe N3 has a limited data center capability, mostly in TCP study, right? And
Yep.
the routing part, I think there are some ongoing efforts. My hope is that once that effort become mature, it can make available to the open source community, then we can actually bring it online through our Web-NS3. So again, we are not developing any of the N3 version myself. We heavily rely on the N3 community to do that. Now, the second question for the AI/ML, we do have another, at the beginning of my talk, we have another feature called Network Jing. If you're interested, you can, this is still in a development phase, but you can actually run that currently with our environment. We do provide that service, even it's in development, but it has a limited use case support. So you can go to the website and see all the information there. And if you want to go deeper, you can contact us. We can set up a meeting and we can discuss offline. Yeah.
Perfect. Okay, we'll have one last question. In one of your demo examples, you changed the parameters. The participant is curious to know what is the least latency or time parameters that you support.
So again, remember that the way that we do this is any of these parameter, right? Whether it's a runtime arguments or the parameter sweep, are all determined by the simulator itself. So you can configure any of them as long as it's supported by your script, right? So here, I probably don't have much time to talk about how you introduce a runtime parameter in script, but you can see that in any of these example, one of the example, let me see that one, that's queue system. This is probably the easy one, right? So you can see that in here, you can add these command line parameters, right, in your script. Once you add that, I mean, this will be just one of any of these parameters that allow you to do, I mean, you add it in the script. So it's not something we support. It's how you write your script. Once you write that script, you can put any of the parameter here to configure it.
All right. So yeah, I think we can go last one. Is there any way or roadmap to give any prompt and generate the script? Maybe something which is NS3 bound script.
Sorry, I didn't get that question.
Is there any way by which somebody can generate the script for NS3 using your tool? Like maybe drag and drop the nodes and then possibly try to get the code out of the topology.
Oh, okay. You are generating the script automatically, right?
Yep.
I think this is related to the question that I answered regarding the visualization or deploying the JSON config, right? My wish list is instead of generating the script, what we are envisioning here is that we just generate a configuration file, which can be a JSON format. And then I can easily generate. That's something that I really want to work on at the next roadmap. Part of the roadmap is to, once the community start building that example using JSON configuration as input, then I can turn that JSON configuration into a graphics, right? Like GUI interface to drag and drop those configuration and then generate the configuration file. Not generating C file, but generate JSON file from the topology that you created with the GUI. Yeah.
Great. I think then we are done with all the questions, Jing, and quite a few people have appreciated this effort in the chat box about getting started with a tool. So thank you very much for giving this talk. It was a pleasure to listen and know about this tool. We'll put up this recording up on the NS3 website, and all the participants will be informed via email. Thank you once again for being with us today and giving.
Thank you so much. Thanks, Mohit. Yeah.
Thank you. Yeah.
Talk to you later. Bye-bye. Yeah.
Bye. Thank you to all participants for attending. Bye-bye.
Recording stopped.